Hello and welcome to another video of mine on antibiotic susceptibility testing. In my previous video, I covered various disk diffusion methods which included Kirby-Bauer and the Stokes method. Today I'll be focusing on various dilution methods which include Broth and agar dilution methods. The dilution method, which is the oldest antibiotic susceptibility testing method that determines the MIC of antimicrobial agent. Before proceeding further, we should be aware with the two terms, that is MIC and MBC. MIC is minimum inhibitory concentration, that refers to the lowest concentration of the antimicrobial that inhibits the growth of the organism, whereas MBC is minimum bactericidal concentration, that is the lowest concentration of the antimicrobial that kills the organism. Two basic types of dilution methods are macro dilution and micro dilution, and in both we can use either Broth or agar method. In the Broth dilution method, we use cation adjusted Mueller-Hinton broth for non-fastidious organism and Mueller-Hinton broth with 5% lysed horse blood for fastidious organism. We make serial dilutions of antibiotics in it, for example 2 micrograms per ml, 4 micrograms per ml, 8 micrograms per ml, and so on within the therapeutic range of the drug. To this antibiotic dilution, we add the standardized bacterial suspension of the test organism, matching finally to the turbidity of 0.5 McFarlane standard. This broth dilution method can be macro or micro depending upon the total broth volume used. Obviously, the volume will be more in the macro dilution, where we use test tubes with a total volume of 1 ml, and in micro dilution we use 96 well microtiter plate with total broth volume of 0.1 ml. After inoculating the test organism, the tubes or the microtiter plates are incubated at 37 degrees centigrade for 18 to 24 hours. The result is interpreted as MIC, that is the minimum concentration of the antibiotic that will inhibit the bacterial growth, and there will be clear broth. Minimum bactericidal concentration is calculated by subculturing all the tubes with no visible turbidity onto an agar plate. The tube with the highest dilution that fails to yield the growth on the subculture plate contains the MBC of an antibiotic. Now coming to agar dilution method. In this, we make dilutions of antimicrobial agents in molten Mueller-Hinton broth with agar media and then pour it into the plates. Then allow the molten media to solidify. One plate of media has one particular concentration of antibiotic, which can be tested for sensitivity against multiple organisms. We make bacterial inoculum to 0.5 McFarlane standard and deliver 0.03 milliliter of it onto the plate with a pipette that can produce 3 millimeter diameter of drop on the media. Multiple organisms can be inoculated on the different grid marked sections of the plate, either individually with a pipette or an inoculating device called Steer's replicator. The Steer's replicator is an instrument with spring-loaded head that is fitted to 36 flat-surfaced inoculating pins about 3 mm in diameter. The head can move up and down in a vertical plane with the help of a piston. The pins dip into the well that contain different bacterial suspensions. The head is lowered into the well, thus sampling approximately 0.03 ml of bacterial suspension onto the surface of the inoculating pin. Next, the head is raised and an agar plate is moved into position and piston is lowered for the pins to touch the surface of the agar. The procedure is repeated for all the antimicrobial agents plates to be tested. Then the plates are incubated for 18 to 24 hours. For result, we look for the circle of growth at the inoculum site. Microorganisms that are sensitive to the concentration of antimicrobial agents contained in any given plate do not produce any spot of growth, whereas resistant ones appear as circular colonies. So, the concentration of the drug where there is no growth is taken as the minimum inhibitory concentration or MIC for that antibiotic. So, in this lecture, I have covered various dilution methods for testing antimicrobial resistance. Hope you enjoyed the lecture. Do give your comments and suggestions for improvements. Also, please like, share, and subscribe the channel for similar videos.